This is CPM Precalculus Chapter 2, number 119. So here we have a triangle, and we want to use it to answer the problems below. So part A says find the exact lengths of the missing sides. Exact means do not approximate, so don't use approximation. Okay? So let's go ahead and look at this triangle. What do we notice? Okay, so the first thing we should notice, it's a right triangle, right? It has this right here, so we're given that it's a right triangle. That's good. Also, one of the sides is 30 degrees. One of the angles is 30 degrees, angle C, right? We also are given one side. So given this, we could use the law of sines, right? We're given one side, and we could use the law of sines to go ahead and figure out, well, what is this side, right, and what is this side? Well, first we would need to know angle A, right? So let's go ahead and find angle A, and we can find angle A by adding up angle A plus angle B plus angle C is 180 degrees. Angle A plus angle B we know is 90 degrees. That's the 90-degree angle. Angle C we know is 30 degrees. Equals 180. So now let's solve for angle A. 90 plus 30 is 120. Subtract 120 from both sides and we get angle A is equal to, not 30, 60 degrees. Okay? So actually just seeing this 30, 90 here, I would know immediately that the other angle must be 60 because this is true. And this is so common that it is a special, right? That means we have a special right triangle. And what do we call that? That's a 30, 60, 90 degree right triangle. So given that it's a special right triangle, I know that the side opposite of 30 degrees is just some value A. Usually I call it A. So I'm going to say A is equal to 5. The side opposite of 90 degrees is going to be 2A. And the side opposite of 60 degrees is square root of 3 times A. Alright? So this makes it really easy because A is already given, right? We have A is equal to 5. So 2A is just 2 times 5 since A is 5, which is 10. Square root of 3 times A is just square root of 3 times 5. And we want to keep our numbers exact, so this is going to be where we stop. So the exact length of the sides, I know that this side should be called little c actually, but I'm going to let it stay as little a, and I'm going to label the sides as AB, right? Side AB is this side AC, and side BC. Okay, so we know AB is given is 5 units. AC we just found is 10 units. And BC we just found is 5 times square root of 3. Alright? And that is the exact lengths. So don't plug it into your calculator and we have those done. Okay? And the missing sides are just these two. Right? This one's already given to us. Alright. Let's go on to part B. Part B asks to write and simplify the cosine ratio for angle A. Well, we know from the acronym SOHCAHTOA, that when we're looking for cosine, it's just the adjacent side divided by the hypotenuse side. So cosine of angle A is equal to the adjacent side divided by the hypotenuse. So that leads us to say cosine of angle A we know 60 degrees is equal to, well, what's the adjacent side to this angle? Well, it's not the hypotenuse because we know the hypotenuse is across from the right angle. So the adjacent side has to be 5. And the hypotenuse we know is going to be right here is 10. And we could go ahead and simplify that because it says simplify in the instructions. 5 divided by 10 is the same as 1 divided by 2. So the cosine ratio of angle A is 1 divided by 2. Alright? Part C, we're asked to write and simplify the sine ratio for angle A. So given SOHCAHTOA, we know sine of angle A is equal to the O is opposite side, the H is hypotenuse. Okay, so this allows us to say sine of 60 degrees here is equal to, and what is the opposite side from angle A? It's just the side that it opens up to. So it's going to be over here. It's 5 times square root of 3 over, and the hypotenuse is still going to be the longest side always across from the right angle, over 10. Okay, we can simplify that again, knowing that 5 cancels with the 10 and becomes 1 times square root of 3 over 2. And 1 times square root of 3 is just square root of 3 over 2. Alright, so that is simplifying the sine ratio for angle A. Alright, so this finishes the problem, and we are done with CPM Precalculus Chapter 2, number 119.